This session, we will first have a short introduction of each of the participants by themselves, and then I'll ask a bunch of questions, and then open the discussion to the audience. So let's start. The speakers are Samuel Charron from Data Publica. So you are a data sergeant, or so some kind of mix between a data scientist and a developer. Then we have Julien Sananikone from Rakuten PriceMinister. You're a project manager there. Then we have Kenji Lefevre from Dataiku, who is product owner, as far as I can remember. And then Benjamin Guinebertière from Microsoft, so tech evangelist for the Azure platform and Azure ML, Azure machine learning as one of those. We have some short presentations, so Samuel, you can start here.
Hi, I'm Samuel Charron from Data Publica. I will talk about Siwada. Siwada is the most powerful company search engine, meaning you can search for companies in our search engine. Why is it the best? It's because we are linking company data, traditional company data like revenue or number of employees to websites. So we are using Scikit-Learn to add value over this data. So basically we are using a big sparse matrix of 1 million websites by 5 million terms. These terms are just some tokens we get from NLTK from the websites we called. And we end up with this kind of page about a company, so you can see that we have terms about the company. You can see a clue of all the important terms on this site. You can find similar companies on the right, so we are again using Scikit-Learn for that. So Siwada is an advanced search engine on companies. We are automatically linking companies to websites to add a lot of semantics. And then we try to add values, like we try to group and find the similar companies by their activity, because we think the website of a company is its activity, basically. We also try to find new customers based on the past customers of big companies, meaning if a bank has like thousands of customers, we can try to find by activity new customers in the same sector and just give them a list of these companies and sort it by relevance based on the revenue, the size of the company, or things like that. We are trying a lot to use everything in Scikit-Learn, because we really think it's interesting. So to do semantic grouping, we are just using TF-IDF vectorizer to just take to have the big sparse matrix. Then we do LSI to reduce the dimensionality, and we end up with spectral clustering. And with some D3, we are doing visualizations where each circle is a group of company in a kind of activity. So here it's from e-commerce market, so you can find some topics about wines, or about, I don't remember what we have here, but really interesting. And it can be done in a near real-time fashion, so like it's something like a minute to compute everything, but mainly just to gather all the documents. And we also are doing semantic targeting. So, for example, if you search all companies doing big data, we do a search. We find all companies in this domain, and then it's like a Tinder. You can just say, okay, I want this company, or I reject it, and we will do a classification in real time, and it implies to have everything about this in memory. That's it.
No, you didn't. See, yeah,
Yeah,
they are the next.
This one.
Yes.
Hi everyone, I'm Julien Sananikone from PriceMinister. I'm manager of the product catalog in PriceMinister. I'm sorry for you guys, but I'm totally ignorant about data science. But anyway, I used Scikit and it works. So I try to explain a little. Well, PriceMinister is about 25 million products. We have more than 150 product types, more than 200 categories. There are many channels where the products come from. So it's quite messy, and I have a lot of problems about duplications of products and categorization of products. So since we were bought by Rakuten in 2010, we start talking about machine learning with Japan and New York, but we are still talking anyway. Last year we built an Institute of Technology in Paris, and I met Vincent Michel there, which is a contributor of Scikit, the library Scikit. And then in a very few time, I just became a guru with Scikit. So actually, I just followed the tutorial, which is very, very clear, and the tutorial about working with text data. So this is the technical part. I don't know if it's really, really interesting, but it's really the base of Scikit. And I have the chance also to have the samples that are already labeled, because we have, as I said, a lot of products in PriceMinister. So I just trained like 1,000 samples for 100 categories. Yes, 100 categories. My point was to do categorization using the titles of products. Well, I just did less than 30 lines of code using Scikit-Learn and PyData, Falcon MicroWise guide, just for the technical part. And in just a few lines like this, I had a very, very, I guess, in my opinion, very impressive results, because 70% of the titles I examined were correct. And we are going to use this library and this result to launch a new product quite soon. I cannot tell much, but you will see. So just to have a glimpse of it, I just typed in some kind of mobile application, chemise verte for those who understand English, and Scikit told me it could be clothes, so vêtements, stationery, fourniture, or maybe plants. So I think that's a good thing. That's it for my part.
Okay, so that's my name. So Azure will be able to host Python in different ways, as I said this morning, but here are a few screenshots. This first screenshot is a Flask web application, and this is the source code that is editable in the browser. So that's the first way of using Azure with Python, where you can host some web apps in Azure. The second way to use Python in platform as a service in Azure is to use it with HD Insight, which is Hadoop as a service. So Python is installed on the node. So you could use, for instance, Hive and Python, and have in the dirty part before the novel part of machine learning. In the dirty part, you can mix and match, for instance, SQL with Hive and just Python code that will just do things in between. So then there's another integration between Python and Microsoft. This is not especially on Azure, but this is the Python tools for Visual Studio, where you can use, in this screenshot, you have on the right, you have a project where you have a virtual environment. In that case, I created a virtual environment coming from Anaconda on Python 3. And then I have a project, and I take some code from the project and I move it to the interactive console, which is in IPython, and then I plot it. So this is a Scikit-Learn code in that case. But the thing that will be more interesting here is Azure machine learning. So we have at the upper left we have ML Studio, the orange box, which is a browser-based studio where you can drag and drop and put modules that will change your data, and then that will apply some machine learning algorithms. And one of those modules is to execute some Python code, and you can execute any Anaconda module that is available in the Anaconda distribution. And then the interesting part of that is that you can make a REST API from that very easily in a matter of minutes, and then you will have the scale out of if you have many clients calling the REST API, then you will have the scalability of that prediction, for instance. And see, this is how ML Studio look. In that case, there's a module which executes R, and then another one executing Python. In that case, Python is used to plot and calculate the area on the curve on a model written in R. So the idea is to mix and match different libraries in a common environment. And in that case, it's just the classical Scikit-Learn classification. I don't know how you call it that, which is plotted inside Azure machine learning.
Hello everyone, my name is Kenji Lefevre, and 10 words for my life. So I come from a pure mathematical background, and I end up playing with data on KL, and now I'm the product manager of Dataiku. So what we do at Dataiku is that we build a platform dedicated to a team of data scientists or business analysts in order to develop quickly predictive application. And we have a metaphor for our product. We call it the Photoshop of the data science. And the idea is that when you have a data project, you need many tools inside at the same place for various tasks. For example, you need to load your data, prepare it, and visualize it. So we have user-friendly way to do that. And then you will produce statistical models, assess this, and finally, you will deliver the results of your analysis to your end user. So you will publish it, and you need to be able to replay your analysis frequently. And because it is dedicated for a team of data scientists, we have different tools that are both very easy to use. So you will just use your mouse in a web browser, or for highly skilled people, you'll have also the ability to code in our product. So on this flow, the blue square are the data, and what you see, the other nodes are just preparation or models. And so you have various languages, Hive, RP, and Python. This is why I'm here today. And so how we use Python inside? The first thing is that you are able to code all the transformation and machine learning using Scikit-Learn, pandas, and all we provide a library so that you can load your data in the form of a stream using iterators, or a data frame using the pandas library. And for the machine learning part, we provide a way to create models just with the mouse. But so the backend for this tool that we have developed inside in home is Scikit-Learn. But if you want to hack this code, we also allow the people to export this into a well-commented Python code that the people will change. And we also provide IPython, the interactive environment for coding in Python, just for two purposes. The first is the ability to do some custom reports. So you will code in your Python code, and you will put some visualization and explanation, and you will export this as a static file, you will, and to the business readers, and you will be able to replay it. And also, it's a great environment for debugging. And we also use Python as a backend for web application. So we provide a small environment to create web application with libraries to load data using JavaScript or Python. And when the data are too big, then it is more easy to use a backend. Then we promote Flask for this task. And so this is used for custom visualization, for example, or when you want to communicate with business end users. It's quite nice to have some dedicated application with visualization in order to explain what you're doing along the data project. Thank you. One more was, this tool is available, there is a community version that is free, so you can download it and try it.
All right, so thank you very much for the introductions. So now I have a first question about what, in your experience, where do you see is the role of Python in the current data ecosystem? Where does it shine, and what are the main limitations of the Python ecosystem? And what do you envision as potential competitors, technical environments that could displace the current situation of Python in the coming years? You can. So where does it shine first?
Well, I think that's what Gail said this morning. The fact that it's easy to develop, it's easy to see the code and so on. So also the fact that it can be used in many environments. As I mainly work on Windows, I'm concerned by that. So the fact that it's in different environments, and also the fact that you can do many things with the same language. I mean, you could do infrastructure as a service with Python scripting. You can do data science. You can do web development and so on. So I think that's a very rich ecosystem in that sense.
Yeah. Well, Python is a great language to start with. It has a very big community, so many libraries are well stabilized now. So when people are starting with data science, they do not have all technical backgrounds, and I guess the first thing is to understand what you must do, but then to have easy code and well-documented libraries like Scikit-Learn is definitely a plus amongst the general tools. For example, compared to R is really nice, but you first have to understand the math to use R. So for example, the documentation of Scikit-Learn, which is really close to the library, is quite rare, I think.
Okay. For me, I'm not a developer. I played a little with Django, so I know a little bit about Python. But I found Scikit-Learn for search very clean and clear, and about documentation also very clear. So it was for me very, very, very easy. Knowing nothing about data science. Well, I studied a little statistics at school, but I could dive into Python really, really quickly.
For me, Python is really good for its documentation for all libraries, because you just go on the Scikit-Learn website and you can just learn everything in just minutes, and that's mainly because of examples everywhere. And I think that's one of the strengths of the language is really this documentation. And then the simplicity, because you can learn it in just, I think it's a matter of days, where for other languages it's really, really slow. But that's one of the weaknesses also of Python is the lack of guaranteed structure, because you can just throw any structure everywhere, and it can it sometimes work, but the next time it doesn't work, just because you don't have exactly the same structure, and you can't really verify that like at compile time.
More disadvantages?
In terms of disadvantages, I would say that the fact that it's not in the JVM could be an issue. Well, there's Jython, but it's in Python 2.5, I think.
7. Almost 7.
Almost 7.
There was a beta yesterday.
Oh yeah, okay. Okay, so that's good news. But that could be an issue because of the Hadoop world and the Spark world who live in the JVM.
And do you see competition improving and in other technical ecosystem?
Well, there's the coolness of Scala on the coming with Spark, but that's the same story with JVM. Maybe this is because of the functional thing. I'm not sure about functional programming in Python. Maybe it's possible. I don't know. But
yeah, and also one is that the best tool is generally the one you know.
Yeah.
And I mean, the people who are coming from R will try to find the libraries to do what Python is already able to do. So I think it's hard to compare in that point of view.
Okay. So yeah, to answer the question about functional programming, it's possible in Python, but it's not a requirement or not necessarily a good practice. So I would say that in Scala it's much more natural. What do you think more? So the second question is not necessarily on Python itself, but more on the use of predictive modeling. And what are the most common successful application of predictive modeling in your experience? So, for instance, I have in mind churn prediction, fraud detection, anomaly detection. We've seen talks about predictive maintenance and marketing personalization. Which of those or others do you think are really important right now, or trending, or based on your experience with your own customers or your own?
I would start with recommendation, but there's a bias because it's part of something we sell through the marketplace, and it's a finished application. It's just you don't have to be a data scientist at all to use it. You just have an SDK and you throw data at it, and you ask for recommendations. So that's something that is quite, I would say, quite easy to sell because you really don't need any data science to use it. So maybe things that are a higher level and that can be used just by developers, mobile application developers, for instance, could be a good fit. And the second one will, and maybe that's an answer from Microsoft Marketing in that case. The first one was on a recommendation, and the second one will be on churn prediction.
Okay.
In terms of verticals, we do at Dataiku food, marketing optimization, and predictive maintenance, things like that. It's hard to tell because I guess in many organizations the difficulty is to start. In fact, when the growth is natural for an organization, that they look for a small place where they have assets in order to increase their revenue. And the biggest difficulty is to start. So I guess the main key point is from zero to something. Yeah, that's the first thing, I guess.
So my main use of Scikit were the one I mentioned about classification, clustering. We also have in mind a lot of use of predictive toolkits such as Scikit, especially regarding images and mobile applications too. I cannot tell what we are doing right now, but it's around these kind of things and recommendations too.
For us, mainly classification. We are using it everywhere just to say, for example, that a company is doing e-commerce or things like that. But also regression is just a good tool just to do some scoring or stuff like that. But also clustering and everything. So nothing.
Which domains do you think are the most impacted by the development of predictive modeling? I would say industry domains. And do you see predictive modeling as some sort of disruptive technology, fundamentally transforming some businesses, or more like an incremental optimization that makes it possible to do existing jobs better or faster or more efficiently?
For us, we are trying to disrupt the B2B thing, so we see that as an asset to accomplish that, and we are trying to just change the way that people are dealing with sales and marketing by just having another view on it, and doing less stuff manually and more stuff automatically.
Which domain regarding commerce? I would say regarding B2B and C2C too, for fashion. In the next 6 months, there will be many things about fashion using predictive modeling.
The selling meters for in the street for when you're parking your car, and so that's basically a device to pay. And they are using machine learning. They have built an application to predict the parking pressure, and this is somehow really changing the core of their business. And so that's one of the key ideas with machine learning is that you can start by selling meters, which is a physical device, by ending selling a pure service where really realize the value of your business.
I would think, as Microsoft, I would think of a natural user interface because of what we see with games when you move in front of your TV, or when you interact with your phone by asking him some questions, or
Cortana,
yeah, Cortana, for instance. And but I would also think of a completely different thing, which is political survey companies, which are statisticians, and as statistics become more used by many people, they have competitions, so they have to move and follow that thing and transform themselves and use also big data and stuff.
All right, thank you. Now about so you have different backgrounds, but at least 3 of you have some kind of data scientist experience. Do you think the way we train data scientists today is good? Do you think like schools, universities, and maybe professional training are doing a good job at training the next generation of data scientists? Or do you think we could improve that to make the training better, more at scale, let's say? And what kind of skills are the hardest to master?
Tough question.
Well, I guess the most difficult skill is definitely to have a data intuition. I mean, it doesn't have to I mean, it's not related to understand the deep you're learning well when you're doing a true data project. that's really the key point. So I mean, I'm not really sure that learning all this at school always helps. To be honest, yeah. So at least for me and the people I've seen learning recently, you can promote people who do not have experience in terms of statistics or even technical background, because there's more and more tools that are easy to use. But people who really who knows what they want and are quite, in fact, skilled quickly. That's my opinion.
So actually, yes, I'm not from a computer science background. I'm an agronomist. I studied not far away from here at Agro Paris. So I did a lot of actually experimentations and field experimentations, and actually I used a lot of statistics. So that's also what taught me about. I did not know at that time. Now it's called data science, but we called it statistics. And maybe, I don't know, yes, maybe agronomy is better at teaching data science than computer science. I don't know.
That's very possible.
Yeah, for me, I don't know if there is a training, because yeah, the value of data science is to transform some data into a product or something like that. So you need to have intuition, but also to be able to render it to your customer, and so it needs some experience and stuff like that. But I think at training you can just learn all the techniques that will make your life easier to process data. That's the stuff you can learn, but then it's pure experience.
Yeah, and the main thing which is important is to learn, because things change a lot.
Well, there are maybe two types of data scientists. The one who are dealing with a data project where they have first to prove that data science is not magic, and then so they have to first use very simple models which are really easy to understand, in fact. And if they are not able to explain what these models are doing, they won't go very far. And then the second type is data scientists that are trying to improve by really small point and percentage a specific use case, because it will yield huge amount of money, and that's completely different data scientists. Yeah, well, Kaggle, so I don't know, or Google, or whatever.
Kaggle, you don't make a lot of money.
No,
So maybe we can open the discussion to the audience. So if you have a question, please raise your hand. So there is a question over there. Where? At the top of the room.
I think it should be okay. I just want to know if there is some blocking package issue related to the old Python 2 versions, or all the ecosystem already migrated to Python 3 version.
All right, so I will repeat the questions for the video. So are there any problems, for instance, related to packages that are enforcing the necessity to use the old Python 2 instead of being able to use Python 3, or as the whole ecosystem migrated to Python 3? So, based on your experience.
What I can say is that, well, I would think of the JVM, for instance, and also I know that which shows in the first place to integrate Anaconda in its in Python 2 instead of Python 3. I don't really know the reason, but maybe that's in terms of number of users and the fact that many things are backported to Python 2. That may be the main issue with Python 3.
Well, same. I think well, we are still stuck to the version 2 because we don't want to face the problems wherever they are, and well, that's the problem when working with open source technology.
My situation cannot answer.
We are using Python 3 everywhere, and we began 2 years ago, and it's not an issue. And since we are doing a lot of stuff related to the web, we need to have a good Unicode support. So Python 3 is the tool of choice here, because Python 2 not that good.
So I co-organise the PyData London group. One of my goals there is to help more companies in London use their data to do data science. Just noting Python 3.4, I shifted to 3.4 a year ago. I encourage many people to do that. I've not heard of anybody ever going back to 2.7, having made the transition, and you've got 4.5 years before the Python ecosystem stops supporting 2.7. So it's better off doing new projects in 3.4, I'd say. My question, I'm particularly interested in what is it that stops companies adopting data science in the first place? Is it technological, lack of data, lack of manpower, lack of vision from management? In your experience, I've been gathering stories. In your experience, what do you see as the biggest blockers?
In my experience, many companies sold me data science as magic. And actually, because we have in PriceMinister quite well-structured data, actually what we can achieve with data science has a very little improvement. So if you come from data, you scatter the big data all over the place, you can do a very huge improvement with data science. But if the data from which you start are well structured, well organized, the improvement is not so big. So, well, but so that's my experience about it.
In my opinion, this is mainly a problem of vision and also power. I guess until recently, the people who really own the data were the ones who were deciding the global strategy of the company, and working with data is just giving more power to data themselves. So decision will be taken very differently, and in order to make this change into the decisional process of an organization, you need to have people who are just giving the vision, and also have the ability inside to explain how things are changing and what impact it will have on the people who are working in the company. And that's, I think, something very hard to address.
Yeah, and the fact that we always hear that we lack data scientists, and so companies say we don't have data scientists, so we won't even try. that could be an issue, and yeah, and also maybe the fact that people who have the vision may be very far away from the technical guys who could do it. So.
Another question? It seems that the recurrent use case of data processing and machine learning is often focused on basically business decisions. Not always, but often. And for me, as somebody working on machine learning, it's frustrating because there's so many things that we're not doing well in our society, in our day-to-day work. And to see this, only going in the business units. So for you, what are the blockers for going further, and do you see a way forward?
Relationship to money. I would say that's the first. That would be the main reason why the first use case are related to business decisions. Maybe because marketing would have marketing questions in the first place. So,
well, I guess in terms of social use of the data, there's a lot education that needs to be handled. It's not a problem of machine learning, it's also a problem of this feeling that the people that they have with data that are gathered around themselves, and it's not clear for most people what kind of service, free service, and true improvement can be give back to the people when they are giving their own data. And I think for now, data related stuff, I just look at bad black magic that are done by big companies, and also the idea that an algorithm can take a decision based on the data is very hard to accept, in fact, because of some I guess moral, hierarchical, and well, also the responsibility. You know, when you decide, when you take a decision, let's think about the health, for example. When you take a decision and to operate or to do some surgery or not, it's hard to just believe an algorithm. I mean, it's not in our gene to do that.
Regarding the sociological aspect, maybe with big data and data science, and maybe Big Brother is not far away, so it can scare maybe. And also, yes, as you say, to give the answers to an algorithm, maybe that seems very sound.
For me, there is also a problem of data, because open data is only rising right now, but 2 years ago you didn't have any open data. So now you can just try to use that to improve your society, but you need to have this data. I can take an example. At Data Publica, we did a map of the department, the French department, that we tried to cluster using some open data when politics were talking about which departments should go together to make the new regions in France. So we tried to do some things, and we know that it has some impacts, but it takes some time also, and also you don't have that much data. So.
To add on my neighbors about privacy, I would say that the fact that anonymization is very hard or impossible could be also an issue, because even if you don't know that the guy is named John Doe, but you know where he lives and where he goes every day and where he goes on vacations and so on, maybe you know him better than himself.
Okay, we'll take one last question and then we'll have the coffee break. So is there one last question? No question? Oh, yeah, okay.
There seems to be with text processing seems a bit late. I mean, natural language processing. There are not so many tools as there are for machine learning. Do you think it will arise these years or not?
So let me repeat the question. So you said that you think that natural language processing and maybe understanding is not as mature as a field for implementation as open source software, for instance, as compared to generic machine learning. And do you think that it's going to evolve and catch up in the coming years?
I think the fact that you have very high-dimensional space for natural language may have been an issue with the democratization of big data. Maybe it will become easier to have more data to feed those high-dimension models.
Well, I believe that with the new buzz world of deep learning and the success they have in the languages, this might change quite quickly. I mean, use case will really change, and so it should be improve. Well, that's my opinion, but future will see.
Regarding natural language processing, what I know is that Rakuten in Japan has done lots of things using Japanese language, which has no space between words, so at least it's even harder. I don't know if I can tell you, but there are many things that are being done at the moment regarding natural language processing.
I think there is a lot of things in natural language processing existing, but it's mainly in English and mainly in Java, I think. But you can find, I don't know, Core NLP is just a big thing in Java, and it has a lot of features, and it does a pretty much good job, I think.
What about the Python libraries for like NLTK?
NLTK is really good at what it's doing, but you have less features available, I think.
Okay.